Hi folks, it's Mrs. Faint again. So we're on lesson 4 of our P1 energy topic, and this time we're looking at environmental and other issues around the energy debate. So make sure you've got something to write on, something to write with, and let's get going. So first up, let's just stop and think. Now this isn't a UK pie chart, this is a global energy consumption pie chart, so it's around the world, but interestingly enough it's from 2014, so it is a little bit out of date, which is quite useful because it allows us to reflect on how things have changed a little bit. Just don't spend too long on this, but you can pause the video and just try and identify which slice of pie, for example, this one belongs to. Almost the same size as over here, so which sources of energy are these? Which energy resources are going into our pie chart here? Okay, so have a little think about that, and then we'll have a look at the answers on the next slide. Off you go. Okay, so how many did you get right? This big one up here was oil, this was coal, and this was gas. Now in the years since 2014 we have moved quite a long way from this picture. So in terms of renewables, we've only got hydroelectric listed here, so all the other renewables are listed in here. Those are the energy resources that can be replenished. This is nuclear, which of course is a non-renewable, along with these 3 fossil fuels over here. Like I said, it's a little bit out of date because we've made big strides in increasing this band of other and this band of hydroelectric here. Okay. But what is stopping us going even further? That's what we're sort of thinking about today. What issues, apart from environmental issues, which are quite substantially in favour of increasing our use of renewables, what other issues are afoot? So what we're trying to do is we're going from what we already know now, which is comparing the advantages and disadvantages of energy resources and their effects on the environment and their reliability and those other things that we've seen in the past few lessons. But we're really thinking about what other issues are there, not just the environmental ones that have been identified by scientists. Okay, so here's what we're supposed to be thinking about, and if we were in class all together, this is what we would be discussing now. We have identified harm being caused to the environment by fossil fuels, so why are we still using them? So I suppose what we have to think about really when we look at the key words up here is it isn't scientists that run the country, the government does. That might be a shame, but if we know polluting gases are bad for the environment, why might the government not want to build other particular energy resources or use energy resources that are going to be more environmentally friendly? Why don't we just suddenly swap to massive wind farms, etc.? And a lot of this has to do with possibly cost, which would come under the economic band there. But then if the government wanted to build, say, a particular wind farm, they might have to consider the implications of where that was, if that was going to cause a problem for the residents in the area, would that affect some of the political scene in that area? These are the sorts of things we're considering. Okay, so our targets for today, if we can identify environmental issues, we're working at a level 4-5 here, but if we can describe some of the other issues, then we're beginning to creep up the scale here. Okay, now discuss is an interesting command word, because you've really got to think about positives and negatives, and usually come up with a conclusion as well, and relate it back to the information you've been given. So just to think about reducing energy use, you can pause the video here, open up the PowerPoint so you can get the link, and look about practical ways of reducing energy usage. Okay, so although the scientists can identify the environmental issues, as I've said before, these are the other issues that we've got to think about. So ethical, whether it's fair or not. Social, so that's to do with all sorts of things with our human beings, where we live, what we think about it, what different groups of people think about it, whether we can consider each other's opinions. This is to do with the financial side, and this is to do with the political governmental scene might be at a local level, might be at a country level. So rather like the exercise we did last year, what I'd like us to do now is take those words from the previous slide, so that's our political, ethical, social and economic, and then see if we can apply those words to these considerations here. Okay, so for example, if it's expensive to build non-renewable power plants from scratch, be that a wind farm, banks of solar cells, a geothermal plant if you were in the right part of a country or a right part of the world, which of those issues would apply here? Political, ethical, social, economic. So what you need to do is write this slide out onto a piece of paper, or if somebody's been kind enough to print that out for you ahead of the lesson, then you can use that, and then just try and put those words in the right places on these examples here. Okay, now there's two sets of these slides, so I'll switch to the next one. So if you need to get this down now, pause the video. Here's the second one. Okay, so this is protest movements and concern about climate change have generated a lot of support from the public for renewable energy resources. And do you remember we briefly looked at a picture of Greta Thunberg on one of the earlier lessons and said that she was responsible for getting a lot of people to start thinking about things that maybe they hadn't done in the past. So what are those four words? Political, ethical, social, or economic could be applied to that slide, for example, to that bit. So you're either going to have to copy these down, or if it's already been printed out for you, you can just work straight on it. Okay, so it's going to be a few minutes for you to work on that, and then you can go, I'll put the answers up for you. Okay, so I hope you had time to look at both of those. Now, some of these may be up for debate, but for example, when we're talking about if it was expensive to build non-renewable power plants, well, that's a cost implication there, so that's got an economical thing here. Whereas on this one here, people are more aware in general of the fact that non-renewables will run out one day and want to prepare for the future. So we're talking about social aspects here. If we're more aware of our non-renewables running out and we want to prepare, then as a society we've got to think about that for future generations. And also the fairness of leaving future generations without access to things like crude oil, which is the source of our fossil fuel, some of our fossil fuel, and thinking about whether that's a fair thing to do. Okay, so see if this agrees with what you had, and if you want to add any more of these in. Okay, so I'm just going to switch on to the second slide now. Okay. All right, so there's some ideas for you, and I hope that's given you a chance to think about other things. So scientists are in control of working out the science of things, but they're not in control of these other issues here. Okay? All right then, so let's have a practice at some questions. Now this is an interesting one, a very mathsy question, but you're asked to complete a pie chart to show the percentage of electrical energy that's generated by each of these resources. Now, I do have a hint slide, so I'm going to let you think about this first of all. Okay, how do you turn these percentages here into a number that's represented on this pie here, this circle? Okay, and for this you will need to know how many degrees there are in a circle. Can you remember how to do it? Okay, well here's a hint if you can't. First of all, check these numbers add up to 100. Okay, because it's percent, that means out of 100. And they don't, so they add up to 91%. So our missing number here must be oil at 9%. Okay, now there's 360 degrees in a circle, so each percentage here represents 3.6 degrees. So if you've got 41%, 41 multiplied by 3.6 degrees, okay, is going to tell us how much of the circle, how many degrees of the circle, that's why we needed a protractor, how many degrees of the circle we will use to represent the gas in this case. Alright, so let's go and have a look at, I hope you paused that there, let's go and have a look at the answers here. So here we go, 147.6% here is for our gas, so that is our biggest sector here, 147 degrees should I say, from our 41%, okay? Alright, so that's what your pie chart should look like. Now, I've rushed through that, so that obviously takes a lot longer to do in practice. So if you need to stop and think about how that was done, remember we're turning percentage into degrees here by multiplying this number by our 3.6 degrees. Okay, all right then, have a go at that, marking that. Now, a slightly harder question possibly would be this one here. Homeowner pays £7,600 to have solar panels fitted and expects to save £950 each year. So calculate the payback time. This is how much time would it take to pay back the cost of having the solar panels fitted in the first place. So it's not actually that hard. A little bit of calculation to do. Have a go at it and we'll put the answers up. Okay, so we've got to take our 7,600 and we've got to divide it by our 950. Okay, and that'll tell us it will take 8 years until we've paid back for the cost of the solar panels, and then perhaps we'll go on saving our £950 each year from then on. Okay, so a higher question would be something like this. Now this is an interesting one. It says compare the capital and overall costs of these energy resources. Capital cost is what it costs to build the plant in the first place. Okay, build and possibly also decommission. But then we're comparing with the running costs as well. So there's an interesting figures here. Okay, so you're comparing. So you could pick a couple and compare them against each other. All right, so capital costs are lowest for the gas-fired power station and highest for the wind and nuclear. And that sometimes people don't think about the wind turbines being expensive to make, but they have a big concrete base, long blades, they've got to be transported into place, so that sort of thing is quite high. Decommissioning costs for nuclear power plants, so here's our fuel here, our uranium fuel, are high because we've got lots of safety precautions to think about. But overall costs, including fuel costs, are lowest for hydroelectricity because the falling water is free. So however expensive it was to build, and this is one of the cheaper ones, the fuel cost is low. So over a course of many years, because the fuel, there isn't a cost for the fuel there, that's just falling water. It will cost to pump it back up at night, of course. But that's why it accounts for low. So those are the sorts of things you could think about. Probably you could talk about some of the others as well. Now at this point, it's worth thinking of going back to your progress sheets and just seeing how you feel about each of these lessons. Remember, you can always use BBC Bite Size if you need to top up some learning, or your revision guide. And don't forget your definition sheets. You can cover up these words. Can you put the definition in place? Can you do it the other way around? Can you give it to somebody to test? Okay, well done. Right, I'll just leave you with this for a few minutes to have a look at and see whether you, how far you think you got. And there'll be some worksheets or questions that you can do that will accompany this lesson. Thank you very much.